Hi, in this video, I will explain to you how you can apply paired sample t-test using Excel tools. Paired sample t-test is used when you are comparing the difference of means between two treatments of the same group. Here we have an example. For example, we have measured the average of errors of workers. This is the list of workers, 20 workers, and these are their errors. For example, they were given a training, a work training or job training. So before they were making, each worker was making these number of errors on average, and after the training we have another column that once they were given the training, after the training there is another data observation that this is the situation of their number of errors they are doing. Hypothesis is what we want to measure. We want to measure, is there any difference or no difference? We say that there is no significant difference. Mean difference is 0, or there is no difference before the training and after the training. So what will be the H1 alternate hypothesis? Alternate hypothesis, we say that there is a difference between mean errors or mistakes, whatever we are measuring. So this is our alternate hypothesis. So what should be the confidence interval? Confidence interval, we assume 95%. 95% confidence interval mean our alpha we can insert here alpha. So alpha, or you can use the sign of alpha. I'm typing alpha is 1 minus 0.95, that will be 0.05. So at this confidence interval level and alpha significance level, alpha is the significance level, so we are going to measure is there any difference or not. Let's see how we can do. We go to data. When you click on the data, you use the data analysis tool pack. If you don't have data analysis tool pack, you can go to file. When you go to file, here is the button option. Click on the option, adds in, and click the go. When you click on the go, there is option, you can check in the box analysis tool pack and okay. So I have already, so I am not repeating it. You can make it enable. So when we go to data analysis, so we are going to search for pair test, t-test. T-test, different t-tests are here. So t-test of for means, it is here. Sample, two samples, t-test pair two sample for mean. Click on this. When you click on this, so this dialog box will open. In these arrays, these are two bins. Here it is asking you for data. Variable 1 range. What is the variable 1? This is your variable 1. Be sure that you are clicking in first data range array. So we are inserting this data into bin. So this data is here. We go for another variable. Another variable is number of errors after the training, average number of errors. So labels we are clicking because we have included labels here. So in your output tables, this will show as before and after. So next is we need an output range. Output should be where? In the same sheet, in the new worksheet. New worksheet will appear here as sheet number 5, or new workbook, that will be totally a new workbook. So in the same sheet there is enough space, so click inside this. Be sure that you have clicked inside this, and then we select this place where our output should be displayed. So click on OK. When you click on OK, this is your output. So in this output there is some complication and many numbers after the decimal place. So go to home and let's make it numbers. When you make it number, so you get each value with 2 digits after the decimal point. Expand it so we can read it easily. So when you are going to read it, we see here important thing, what is the t statistics. This is your t statistics. And what is the degree of freedom? This is the degree of freedom. Was it two-tailed test or one-tailed test? we will assume this two-tailed test because we say that there the mean is 0. So we cannot assume two-tailed. We say that mean is 0. So difference of mean will be more than 0. Okay, so that will be one tail. Difference of mean can be less than 0. If we say less than 0, this means a number of errors have increased. So in both cases, this is open. Either value can be more or value can be less. If we fix here some number greater than that, less than that, then it becomes one tail or in one direction. So this is critical value. Critical value means T critical, what you take from the table. So T critical value is 2.09. Okay, this is what in manual calculation you see using table. So P value for two tail, this is 0.0. These are your important values. But one thing you need, first of all, we need to know about the mean and standard deviation of each group, because in reporting you need that. For that, again you go to data, or you can do it before, no problem. Go to descriptive statistics, click OK. For descriptive statistics, we need this range of data observation, set of observations here, labels because we are going for that, and output. When we go for output, we say that let's display output here. So very important to check this box, statistics, summary statistics. So this is coming, so let's make it like number, so values will be small, easily we can see. So here you can see very clearly that what kind of information, descriptive statistics or nature of the data for each sample is going on, have been produced. So this is the mean of first, this is the mean after, this is the standard deviation before, and this is standard deviation after. These values we need, mean and standard deviation. So what you will do, you will write your conclusion. You will write conclusion in a way that you can say means are significantly different. Why means are significantly different? Because you see here p value is less than 0.05. So therefore we reject null hypothesis H naught. When we reject that, what does it mean? This means we accept H1. Okay, or you can write this otherwise. With the means of that, you can say that employees with mean equal to this 3.05 mean equal to 3.05 and standard deviation. What is standard deviation? 1.32 equal to 1.32. Okay, so you are writing this, and employees or workers, whatever you want to write, it does not make a difference. Employees or workers. Okay, what is their mean? Their mean is 1.35, mean equal to 1.35 and standard deviation equal to 0.81, standard deviation equal to 0.81. okay, has significant difference. Significant difference at what? F equal to, what is the degree of freedom? Degree of freedom here is 19 19 and p-value is equal to 0.05. P-value is the criteria. This is actually your significance level. So this is telling the probability of rejecting the null hypothesis. So you can say that here p-value is less than the cutoff value, less than when it is less than or equal to 0.05, we reject the null hypothesis and accept the alternate hypothesis. So in this way, you can compute the difference of mean of paired sample.